Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is smallest subarrays with maximum bitwise OR. Now, the problem category is of medium level, and I would say yes, it is a medium level of problem. But after watching this video, after understanding the problem and the solution approach, you are going to find this particular problem easy to solve. Now, the given input in the problem is an array of integer, and let us call it as nums. And the output we need to find, we need to output another integer array such that in this integer array, every element, each element at every index I is going to represent a length of smallest subarray. This subarray should be the smallest possible. Now, what is this subarray? This subarray will start at index I in the original array nums and will have a maximum possible bitwise OR. Try to find a subarray which is starting at index I and having the bitwise OR as the maximum possible. This might be confusing, and now let me try to explain you this with an example, and then everything is going to be clear. The input given in the problem is an integer array nums, right? The elements are, let us say, 1 0 3 2 1 1. There are total 6 elements in my array, so I have to output another array of length 6. Basically, for each index I have to find a value. What is that value? For each index in my integer array nums, I want to find a subarray starting at this index and having the bitwise OR as the maximum. But we need to select a subarray with minimum possible length. For the output we need to give is the length of smallest subarray. Alright, let's try to understand it more. Let us say the elements given are 1 0 3 2 1 1. Let us not focus on the output for now. Let's focus on small parts of what we need to give as the output. For this particular element, which is at index number 0, we need to create a subarray starting at this element and having the maximum possible bitwise OR. Now, there are two things to understand here. If you want to find the smallest subarray starting at any index, that subarray is always the element itself. That is, if I want to find the smallest subarray starting at index 0, then this particular array, an array having one element, the element 1 itself, is going to be the smallest subarray. But we need to find the smallest subarray which is having the maximum bitwise OR. If you start from this point, the bitwise OR as of now is 1. If you add this element, it is still 1, right? If you add this element, it is 3. If you add 2, it is 3. If you add 1, it is 3. If you add 1, it is 3, right? So from here, what we can understand is, if I start creating a subarray starting at this element, I am going to have the maximum bitwise OR which is possible as 3. Let's store the maximum bitwise OR for each element in this particular row, BO, which is the bitwise OR, the maximum bitwise OR. But see, the thing is, before you actually solve the problem, you need to understand a very important fact about bitwise OR. What is bitwise OR? How does bitwise OR behave? One of the more important thing which you need to understand is how to perform bitwise OR. For example, if I start with none, if I start with empty data, the bitwise OR is going to be 0 initially. If I have one data which is 1, then the bitwise OR of 0 and 1, this will be equal to 1. But how? I will tell you how. So that you need to understand that the problem says that the bitwise OR of a subarray will be equal to the bitwise OR of each element. That is, if I have a subarray, this one, having 4 elements, 1 0 3 2, then the bitwise OR of this subarray will be 1 bitwise OR 0, bitwise OR 3, bitwise OR 2. That's what the question says. Now, if I start with an empty data which is having a bitwise OR of 0, and I get to see this element is 1. So if I convert 0 into binary or bits, it will be 0. 1 in bits will be 1. 0 and 1, if you take the OR of 0 and 1, it will be 1. Now this element is actually equal to 1 in decimal, right? So once you get to see this element, the bitwise OR will be equal to 1, right? Starting from this array, I can actually create another subarray which can have the bitwise OR more than 1. And we need to maximize the bitwise OR, right? So what you need to understand is, for every index, try to find out what is the maximum bitwise OR which is possible. So if I start with 1, it will be 3. If I start with 0, then it will be 3 again, because I can say 0, then bitwise OR 3, bitwise OR 2, then 1, then 1. All the other elements, basically all the other elements. As of now, we are considering all the elements of our subarray starting with this particular data. Later on, we are going to find out a smaller subarray. So for this, if I try to find out the maximum bitwise OR, it will be 3. For this also, it will be 3, because we can say 3, bitwise OR 2, bitwise OR 1, bitwise OR 1. So it will be 3. Talking about 2, starting from 2, it will be 2, then bitwise OR with 1 will be 3, bitwise OR with 1 will be 3, this will be 3. Now starting with 1, what's the maximum bitwise OR possible? So I can say 1 bitwise OR 1, this is actually equal to 1. So the maximum possible is 1, and similarly for this one also the maximum possible is 1. As of now, for each of my element, I have considered the biggest or the maximum subarray. Starting from 1, I considered all the elements. Starting from 0, I considered all the elements. Starting from 3, I considered all the elements, right? Now, we need to find the smallest possible subarray starting at this particular data, such that the bitwise OR is still 3. That is, if I consider all the elements, the bitwise OR is equal to 3, right? But can we consider less number of elements? Can we consider a smaller subarray which has the bitwise OR as the maximum? Yes, we can do it, and that's a property of bitwise OR. That's the property which you need to understand. If I talk about bitwise OR and I take the bitwise OR of 1 and 0, this will be 1, right? Now from this result, if I take the bitwise OR with 3, this will be 3. That is, as of now I am saying 1 bitwise OR 0 bitwise OR 3, this will be equal to 3, right? Now the thing is, what you need to understand about bitwise OR is, bitwise OR is a progressive operation. That is, its value is never going to decrease. If I take the bitwise OR of 1, 0 and 3, and if the value is 3, now if you take the bitwise OR of 3 with any other number, let us say x, then the output is never going to be less than 3. That is something which you need to understand. So what we can understand from here is, if I consider a subarray starting at this index, and if I consider the complete subarray, and its bitwise OR is 3, right? And now we are asking to create a subarray which has a smaller length, whose bitwise OR is still 3, then it is possible. And let me show you how. If I consider the first 3 elements, that is, if I consider a subarray starting at 1, but not considering whole array, but just considering the first 3 elements, which is 1, 0 and 3. If I say 1 bitwise OR 0 bitwise OR 3, this will be equal to 3, right? Which is actually the maximum possible. And the reason is, if I start taking the bitwise OR with other elements as well, that is 2, 1 and 1, that is 3 bitwise OR 2, bitwise OR 1, bitwise OR 1, the value will still be 3, because we know that the value is never going to decrease, but it may remain the same. That is, if we just consider the first 2 elements, the bitwise OR of 1 and 0 is 1. I consider another element which is 3, the bitwise OR now becomes 3. Now if I consider any more elements, 2, 1, 1 or any elements, it is never going to be more than 3, and the reason is, we have already considered all the elements, right? And the maximum found was 3. Now we just considered 3 elements and still we find the output or the bitwise OR as 3. So we can say that starting from this element, the maximum bitwise OR possible is 3, and the smallest subarray which can have the output as 3 is going to be 1, 0, 3. That's your smallest subarray. The length of this smallest subarray is 3. So now let us start creating our result, our output array. For this index, the output will be 3. These 3 elements subarray is the smallest subarray for which the bitwise OR is the maximum. We are not considering the bitwise OR of the whole array. We are considering the bitwise OR of the array starting at that particular index. For this index, we are considering the whole array, but for this index, we are considering the elements from this index up to the end of the array. We are not considering 1. Similarly, for this index, we are considering this array 3, 2, 1, 1. For this element, we are considering this array 2, 1, 1, right? Now let us try to find out the result for other indexes as well. We can do it very quickly. We can say for this particular element, the maximum possible is 3. The smallest subarray is 0, 3, right? 0 bitwise OR 3 will be equal to 3. We can say this is the smallest subarray and the length is 2. For this particular element, the smallest subarray will be 3 itself. That is only one element which is 3, for which the bitwise OR is the maximum, which is 3. So I can say the length will be equal to 1. For this particular index, the smallest subarray will be 2, 1, because the maximum bitwise OR is 3. 2, 1 can create the maximum bitwise OR as 3. Basically 2 bitwise OR 1 is actually equal to 3. So we can say the length is 2. For this element, the maximum possible bitwise OR is 1 and not 3. Because starting from this, if I consider all the elements, then the bitwise OR is 1. That's the maximum. But we don't need to consider all the elements starting from here. We can just create a subarray of one element, which is nothing but 1 itself. And that is why the length is 1. And similarly, for the last element, the maximum possible is 1. The subarray is 1 itself, the same element, and the length is 1. So this is how you are finding the output for each of the indexes, and this is your final output 3, 2, 1, 2, 1, 1. Now let us focus on solving the problem. If this is your input and this is your output, what is the intuition behind solving the particular problem? See, the first thing is which you need to understand is you need to create a result array which is going to have some data. The number of data which this result array is going to be equal to the number of elements in my array, in my original input array. That is because I have to give an output for each of the index. Now let's do one thing. Let us consider the initial result for each index as 1. And let me tell you the intuition behind this. See, the thing is, if I consider this element, and as of now I don't know about other elements, then starting from this element, the maximum bitwise OR will be equal to the element itself. And the subarray will be a subarray with the element itself, right? And the length will always be equal to 1. So right now we are considering that we just know about this element. So the maximum bitwise OR will be 1. The length of the subarray will be 1 because the subarray itself will be 1 only. Similarly, for this element, if I don't know about other elements, then I have just one element and the maximum bitwise OR possible is 3. What is that subarray? The element 3 itself. The length is 1, right? That is why initially this is our length for each of the indexes. Now let's do one thing. Let's try to make use of the fact that bitwise OR is a progressive operation. Its value will always increase and will never decrease, right? Now if I talk about this element, as of now the value is 1, right? The bitwise OR is 1. Let us say we are trying to build the bitwise OR for each of the points. At this point it is 1. Now when we see the next element, what do you understand when you see the next element? Let us say you are having an array of 2 elements. What do you understand when you see this element? See, the thing is, when I see this element, the first thing which I need to understand is, as of now, the bitwise OR is 1, right? For the previous element. When the new element is seen, when we see a new element, then this new element can either increase the existing bitwise or may not change the bitwise OR which is existing. For example, I can say bitwise OR of 1 and 2 is equal to 3. 1 got increased to 3. But if I say bitwise OR of 1 and 0, this will be equal to 1. 1 is still equal to 1. So when we see a new element, because the thing is, for this data, I have to consider all remaining data, right? As of now, let us say I have seen 1 and 0 only. I know about 1 and 0 only. So I can say for this data, the maximum bitwise OR possible is the bitwise OR of each element. Then we are later on going to find out a smaller subarray which is going to have the same bitwise OR. But for now, if I consider this element, which is the next element which I have seen, so I can say my bitwise OR, which is as of now 1, can either increase, right? If I see a new element, or may remain the same. I have just two conditions. It can either increase or may remain the same, right? Now the thing is, if this bitwise OR increases, then we are going to deal with it differently. But if it remains same, let us say this element is not affecting anything. If this element is being added to my existing bitwise OR, we are not having any change. It means that for this particular index, this element is not required. I mean to say, let us say we have seen two elements, 1 and 0. As of now, I am considering that their maximum or best result is 1 itself, right? Now what we are doing is, we are saying that if the elements are 1 and 0, if I see 1, the maximum bitwise OR possible is 1. If I see a 0, see, the thing is, for the first element we don't have a previous, right? So don't worry about this. But for the second element, we have a previous element, and this particular element can change the maximum bitwise OR for the subarray starting for the previous element, right? But let us see, is this actually changing it or not? So we can see that if we take the bitwise OR of this 0 with the previous existing answer, which is 1, this is the existing bitwise OR. So it is not changing its value. The 1 is still 1, right? 1 bitwise 0 is still equal to 1. So don't worry about this as of now. Worry about this element. For this element, the maximum bitwise OR is 1, right? Which is actually coming from a subarray of one element, which is 1 itself. It doesn't really need to increase the size of the subarray, because if we increase the size of the subarray, now the subarray is 1, 0 for this particular data, for this particular index, the length is 2, right? But the bitwise OR is still 1. So why to consider this element, right? So you don't need to consider this element. So we can say, as of now, the maximum bitwise OR is still 1, and the answer is 1 and 1 for both these elements. Why? I will tell you why. For this element, I don't need to consider this. So the subarray is 1 itself, right? And the length is 1. For this element, let us store the previous best bitwise OR, and the reason is bitwise OR is a progressive operation. It may increase. It will not decrease, but it may increase going forward. It may increase. So even though for this particular element, as of now, 1 is the best answer, this may increase because we might see a bigger value, which might actually increase the bitwise OR for the elements for the subarray starting for this index as well. It means that every new value is going to affect or going to increase the bitwise OR of the previous values, right? It may increase. If it doesn't increase, for example, this doesn't increase the bitwise OR, so we are not considering this. As of now, the result is 1 and 1 itself, right? But later on, it can increase, right? So what we need to do is, at every point, we are going to see if we add this element, if we take the bitwise OR of this element with the previous best answer I had, is this going to do some change or not? If it doesn't do any change, no worries. We don't need to do anything in the result, because if it doesn't do any change, our result is the best as of now. But if it does a change, then we need to worry about this. Then we need to process it. Let us see how. If we talk about the next element, which is 3, and as of now, I'm trying to build the intuition to solve this, right? So we are not doing anything out of the box. We are not doing anything which is unknown to us. We are just using the facts which we know about bitwise OR, right? So when we see the next element, now this next element can affect the maximum bitwise OR of the indexes which are before this, right? Can affect for this one and this one both. Now, if I take the bitwise OR of the existing best answer and 3, which is 1 and 3, if I take the bitwise OR of 1 and 3, this will be equal to 3. It means that if you know about this element, now the bitwise OR is 3. If the bitwise OR is 3, it means that the bitwise OR for the previous elements are also going to be 3. That is, the maximum bitwise OR for array, for a subarray starting at this, is not 1. It should be 3. Although it was 1, then still 1, but the next element made an increase, and that is because this is a progressive operation. It may increase, it will never decrease, but it may increase, right? So the moment I see an increase, the moment I see that this particular data is not equal to the previous one, it means that there is a change. The moment I see a change, what I need to do is, I need to do a change in the result of my previous indexes. What are the previous indexes? This is the previous index and this is the previous index. Now, when we do a change for this element, I would say that this is the current index. This is the current element at which I got the better answer. I got a better bitwise OR. The index of this is 2. The index at which I'm trying to change is 0. From index 2 to index 0, the length is actually equal to 3. because we are considering the index number 0, index number 1, index number 2. How to find the length? It will be the bigger index minus the smaller index plus 1. This is equal to 3. That is, starting from this element, I need to create a subarray till this element so that I can get the maximum answer. As of now, right? The length is equal to 3 now. So I can say the length is equal to 3, and also this value will be 3 now. Means the maximum bitwise OR for this particular element is not 1 but it is 3. Similarly, we are going to do a change for this as well. We are going to say the maximum bitwise OR for this is 3 now, and the length will be 2. Why the length will be 2? The reason is this element is at index number 1, the current element is at index number 2, so the length is 2 minus 1 plus 1, which is equal to 2, because the array itself, the subarray itself is 0, 3, which is going to have the maximum bitwise OR for this particular index. So the moment there is a change in the bitwise OR, earlier it was 1 and 1, which is fine, but now there is a change. At that moment, we need to update the value. We need to update the result, and we need to update the bitwise OR. Now the next element we see is 2, right? Before I move on to this 2, you will notice that we are now starting to create the result 3, 2, 1, 3, 2, 1, right? Now the next element is 2. The moment I see the next element, what we understand from here is what is the bitwise OR of this 2 and 3. The bitwise OR of 2 and 3 is actually equal to 2 bitwise 3, which is 3. It means that having this element is not going to do any effect for the previous elements, because the bitwise OR is still 3. If there is no change, then why should we even consider these elements for the previous indexes? So there is no change for the previous indexes, right? And if there is no change for the previous indexes, it means that this particular bitwise OR will not be 3, but this will be 2. And let me tell you why. This is 2, and the reason is we are trying to create a subarray starting from this element, right? Starting from this element, this is the maximum, because this element is not going to affect the bitwise OR for 3, for 0, for 1. And that is why we need to create a subarray starting from this point whose bitwise OR is 2. It should not be 3, right? And similarly, let me do a correction. Earlier I told you that when you process 1, it will be 1, which is fine. When you process 0, this should be 0 and not 1. This will be 0. As of now, the bitwise OR at this point will be 0, because of the same fact that the bitwise OR, to take the bitwise OR of the previous element, which was 1, with the new element 0, if it is not changing, then there is no need to do any change for the previous indexes, and for the current index is 0, it will remain as 0 itself, the element itself. So similarly, if we start creating a bitwise OR from this index, then it will be 2, because this is not going to do any change for the previous elements, right? Now if I take the next element, which is 1, so at this point, when you take the next element, which is 1, take the bitwise OR with the previous element, is this 1 doing any change in the previous element? Yes. If I take this 1 and I take the bitwise OR with the previous element 2, then at this point I can say bitwise OR of 2 and 1 is equal to 3. Means that having this element is going to increase the bitwise OR. It is going to increase this to 3, right? So this can be 3 if you consider two elements, which is 2 and 1, right? The biggest subarray as of now is 2, 1, right? 2, 1 is going to have the bitwise OR as 3, right? So for this point, the bitwise OR will not be 2 but 3, right? But now we need to update the result as well. The moment we see a change, was 2, it got changed to 3. So we need to update the result. Now the result will be how much? You need to understand this. This is at index number 4. This is at index number 3. I can say 4 minus 3 plus 1, which is equal to 2. And the reason is, as of now, we are considering two elements, right? So we can say this will be 2. I need to do a change here, but whenever there is a change, you need to do a change for all the previous data. But now you will notice that when you add this data, it does a change. It was 2, then it became 3, right? So it is actually doing a change for this element, but for the previous elements, there is still no change. The maximum possible answer is 3, right? If you take this 1 with the previous element with this particular data, that is 3 bitwise OR 1, this is still 3, right? So this 1 is doing a change for this particular current data. It was 2, it became 3 after taking the bitwise OR with 1, but it is not doing any change for the previous data. So still we are not going to touch the previous data. We are just going to do a change in this one. So now the answer is 2. Now let us see the next element. The next element is 1 itself. If this is 1 and I take the bitwise OR of 1 and the previous best answer we have, so it is 1 bitwise OR 1, which is equal to 1, right? Now at this point you need to understand that there is no change. It is not going to change. This new element is not having any effect. So the previous data is not going to be updated, right? And if the previous data is not going to be updated, for sure this is not going to affect my other previous data. So for this data, there will be no change in the result. It is going to be 1. And similarly for this data, there will not be any change in the result. It will be 1 because we don't have any more data, right? So now this is the final result we have: 3, 2, 1, 2, 1, 1, 3, 2, 1, 2, 1, 1. That is what we need to do. So now let me go back to the code editor and let me try to show you how the code or how the solution for this particular problem will look like. So first of all, we are going to create a result variable, which is going to be an array. Every element will be 1, and this array will have total length of nums elements. Next is we run a loop for index I in the range of length of nums. Then this is our current element, right? Current is equal to nums of I. Then let us find the previous index because we need to refer to the previous data. So let us say previous index will be I minus 1. Now we are running a loop to check for a condition that while my previous index is more than equal to 0, that is, while when we are tracking back the previous elements, we just need to track it till the index 0. Before index 0, there are no elements, right? And the second condition is, if my current element, if I take the bitwise OR with the previous data and the current element, and if it does any kind of change, when the change will be done, when this will not be equal to the nums of previous. See, the thing is, we are updating the nums of previous, that is, we are updating our original nums array with for each index, and that will be equal to the best bitwise OR value for that index. So we are just checking that if for the previous element, if I take the bitwise OR of the previous element and the current element, and if these values are not equal, it means that this current element has done a change on my previous data. And if it has done a change, then I will have to update the result for the previous indexes, right? So we can say that the result of previous will be equal to the current index minus the previous index plus 1. That's the new length. Now let us update the bitwise OR for the previous data. So nums of previous will be equal to the nums of previous and the bitwise OR with current. And we are now going to decrease the previous index to go back more to see what are the different data we can update. Now after this loop is completed, you are going to have the result. You are going to have this result variable updated, and this is something you can submit. This is the complete code, and this is something you can submit, and this is going to pass all the test cases for this particular problem. So you can see that the runtime is really good. The memory used is good as well. So we have solved this particular problem in a very efficient manner. So guys, I think that is it for this video. If this video helps you to understand the problem and the solution approach along with the intuition, then make sure that you hit that like button. And if you are not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I tried something new, guys. For the past few days, I tried to live stream and solve the Leetcode problem of the day along with you. The response was good, but I think from understanding perspective, as of now, you might not be ready for my live stream. But if you are, then make sure that you put it in the comment box. I can live stream and show you the solutions, solve the questions with you as well. But for now, I will continue this videos where I will solve the Leetcode problem of the day. But if you want me to solve it live, then you can comment it, and based on your response, I can act accordingly. Alright guys, I will see you in the next video. I want to see you in the next video. Thank you for watching this one.